Lab 1, Charge Tapes. Purpose: observe the electrostatic interactions between two pieces of tape and use our observations to calculate the amount of excess charge on one of the pieces of tape as well as the amount of electrons transferred. The fundamentals: Newton's second law, which we use to find the gravitational force. Coulomb's law, which we use to find the force between two charged objects. Models: the tape is represented by a point charge. The results of this lab: the U-tape repelled the other U-tape. The pieces of charged U-tape were found to be positive. The charge on each piece of tape was found to be 4.364 times 10 to the negative 9th coulombs. The U-tapes were each deficient of roughly 2.73 times 10 to the 10th electrons. Models: each piece of charged tape is represented by a point charge. Assumptions: tape is treated as a point charge with all charge concentrated in the center of the tape. Both pieces of tape have the same charge. The charge was evenly distributed along the length of the tape. Experiment: the system was tape B and tape A. The surroundings was everything else. Our initial conditions were 3 pieces of neutral U-tape, each on top of a similar sized piece of neutral base tape. Details: one piece of U-tape became charged when it was quickly pulled away from the base tape, with electrons either being deposited onto the base tape or electrons from the base tape being pulled onto the U-tape. This piece of charged tape was hung by a negatively charged plastic pin to determine the charge of the U-tape. Next, the charging process was repeated with the remaining U-tapes. Tape B was set between two objects and tape A was set below it. The measurement of the distance tape B raised was taken so we could calculate the charge of the tape. First test: a charged piece of U-tape was observed to be attracted to my hand. It was next observed to be attracted to a plastic pin, which was said to be negatively charged. This means that the U-tape is positively charged. Second test: the data we had: the length of the tape is 0.175 meters, the width is 0.0127 meters, the mass is 0.000175 kilograms, and the separation distance from tape A to B is 0.01 meters. Calculations: the force of gravity is mass times acceleration. In our case, that was negative 0.001715 newtons. And we can find the charge on the tape Q by setting the force of gravity equal to the force of tape A on B, then solving for Q, since the net force in the y direction is 0. And I did this here. I did this here. The electron deficiency on each piece of tape was the charge of tape divided by the charge of the electron, which in our case was 2.73 times 10 to the 10th electrons. Calculations continued. Number of atoms on each piece of tape was solved for by the area of the tape divided by the area of the atom, and this was 2.2225 times 10 to the 17th atoms. Ratio of electrons to number of atoms: we had 1.23 times 10 to the negative 7th electrons for every one atom, and our sources of error were the tape discharging onto our hands/other surfaces, and tape charges might not be equivalent, as well as imprecise measurements are always a factor. Here's my code. I initially set up a few constants that we would use later. Then I created my particles, here. Next, we print out a few forces, and just to make sure we know what they are. We'll see that later in the output. And then next we have the vectors, which we'll see as well. Next, we calculate the charge here and print that out. So here's this. Here's our point charges. Here's our vectors. And then here's the information we had printed out. Now our discussion. What if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tapes and other charged objects? So the results would be the same because opposites attract and like charges would still repel. Switching electrons and protons charges would not change that. It would just make the charge we'd calculated negative. Now, why is it important to handle charged tapes as little as possible? What happens when charged tapes come into contact with your hands or other objects? Now, this is important because the tape would discharge as it would pick up electrons that it comes into contact with, which would mess with our calculations. So it's best not to let that happen.